questions. Yes, we were doing definite integrals by using properties. Let's start with another question. Next question is integral of x tan x upon x tan x upon sec x plus tan x and the limit goes to 0 to pi. Again the same property which will be used. Integral of 0 to a f of x dx is equals to 0 to a f of a minus x pi minus x tan pi minus x upon sec pi minus x plus tan pi minus x. Now tan 180 minus theta, or we can write it as, first we can simplify by putting tan as sine upon cos. X sine x upon cos of x. Sec is 1 upon cos and tan is sine upon cos. So it becomes x sine x upon 1 plus sine x dx and the limit goes to 0 to pi. X sine x upon 1 plus sine x. Now let it be 1. Now apply the property integral of 0 to a fx dx, 0 to a f of a minus x sine pi minus x upon 1 plus sine pi minus x. Sine 180 minus theta is sine. Pi minus x sine x upon 1 plus sine x dx, limit is 0 to pi. Now add 1 and 2. Sin x is constant. Take sin x common. Pi minus x plus x upon 1 plus sin x. Pi sin x upon 1 plus sin x. Sin x upon 1 plus sin x. Now rationalize it. Sin x minus sin square x. A plus b, a minus b is equals to a square minus b square, and 1 minus sin square is equals to cos square. Sine upon cos is tan, sec x tan x, and sine upon cos is tan square. Now we didn't have the direct formula for integral of tan square x. So instead of tan square x, we use the property here sec square x minus 1. Identity use करेंगे हम sec x tan x minus sec square x minus 1. Now integral of sec x tan x is sec x. Integral of sec square x is tan x. And integral of 1 is x. Limit is 0 to pi. Sec pi minus tan pi plus pi minus lower limit sec 0 tan 0 plus 0. Cos pi is minus 1, so sec pi is also minus 1. Tan pi is 0. Cos 0 is 1, so sec 0 is also 1. Tan 0 is 0. Pi minus 1 minus 1. So I is pi into pi minus 2 upon 2. Pi into pi minus 2 upon 2. Next is integral of x upon sin x plus cos x, and the limit goes to 0 to pi by 2. Again the same property, 0 to a f of x dx is equals to 0 to a f of a minus x sin 90 minus x plus cos 90 minus x. Sin 90 minus x is cos of x and cos 90 minus x is sin x. Add 1 and 2. Pi by 2 x plus pi by 2 minus x upon sin x plus cos x dx. Limit is 0 to pi by 2. Pi by 2 is constant. 1 upon sin x plus cos x dx. Limit is 0 to pi by 2. इसके जैसा हमने सेम क्वेश्चन किया था, क्वेश्चन नंबर 31. Same limits थी 1 upon sin x plus cos x. By putting sin x as 2 tan x by 2 upon 1 plus tan square x by 2 and cos x as 1 minus tan square x by 2 upon 1 plus tan square x by 2. By use that you can try it by yourself. Same as question 31. Now the next one is, if f and g are continuous on closed interval 0 to a and satisfies f of x is equals to f of a minus x and gx plus ga minus x is equals to 2, then we have to show that 0 to a fx gx is equals to 0 to a f of x dx. Now take this function 0 to a f of x gx. Now f of x is equals to f of a minus x and gx is equals to g of a minus x. We use the property here. Integral of 0 to a fx dx is equals to 0 to a f of a minus x dx. Now f of a minus x is equals to f of x and g of a minus x is equals to 2 minus gx. 2 fx dx minus gx fx dx 0 to a. Here the function is also same. So 2 times 0 to a fx gx dx is equals to 2 times 0 to a fx dx. So fx gx is equals to integral f of x gx dx. Now the next one is integral 0 to pi by 2 x sin x cos of x upon sin power 4 plus cos power 4 x dx. First use the same property. Integral 0 to a fx dx is equals to 0 to a f of a minus x sin 90 minus x cos 90 minus x upon sin 90 minus x plus cos 90 minus x. Sin 90 minus theta is cos theta and cos 90 minus x is sin x. Cos x sin x upon cos 4x plus sin 4x. Pi by 2 sin x cos x upon sin 4x plus cos 4x minus x sin x cos x upon sin 4x plus cos 4x. Again this is the given integral I plus I, 2i is pi by 2 integral sin x cos of x upon sin 4x plus cos 4x dx. Now divide the numerator and the denominator by cos 4x. 2i is equals to pi by 2 sin x cos of x upon cos 4x. Sin upon cos is 10 and 1 upon cos square is sec square. Sin 4 upon cos 4 is tan 4 of x plus 1. We can write tan 4 as tan square x square. Now put tan square x as t. Because we have derivative of tan square x in the numerator, derivative of tan square is 2 tan x. Derivative of tan is sec square x. Tan x sec square x dx is dt upon 2 1 plus t square. Now when x is 0, t is tan 0, and when x is pi by 2, tan pi by 2 is infinity. I is pi by 8 Integral of 1 upon x square plus a square, 1 upon a, tan inverse x upon a. Tan inverse infinity. Infinity is value for pi by 2 and tan inverse 0 is 0. So pi square by 16. Now the next one is integral of 0 to pi x upon 1 minus cos alpha sin x. We have to prove that this integral is equals to this. First, I is 0 to pi x upon 1 minus cos alpha sin x dx. Now again use the same property. 0 to a fx dx is equals to 0 to a f of a minus x. Sin 180 minus x is sin x. Zero to pi, pi upon 1 minus cos alpha sin x minus x upon 1 minus cos alpha sin x. This is the integral which is given. I plus I is 2i, 0 to pi. In this integral, instead of sin x, we use the value 2 tan square x by 2 upon 1 plus tan square x by 2. Pi is constant. 1 plus tan square x by 2 minus 2 cos alpha into tan square x by 2. 2 tan x by 2 upon 1 plus tan square x by 2. Now 1 plus tan square is equals to sec square. 1 plus tan square x by 2 minus 2 cos alpha tan x by 2. Now again we have the derivative of tan here. So put tan x by 2 as t. Derivative of tan is sec square. Derivative of x by 2 is 1 by 2. When x is 0, tan 0 is 0. And when x is pi, t is tan pi by 2 infinity. So the limit goes to 0 to infinity. Sec square x by 2 is 2 dt upon 1 plus t square minus 2 cos alpha into t. Now add and subtract. Have coefficient of t square. Coefficient of t is 2 cos alpha. So add and subtract cos square alpha. T minus cos alpha whole square. 1 minus cos square is sin square. Now integral of 1 upon x square plus a square. 1 upon a tan inverse x upon a. tan inverse infinity minus tan inverse cos upon sine cot. Tan inverse infinity is pi by 2. We can write it as tan pi by 2 minus alpha. Tan 90 minus that is cot. Pi upon sine alpha, pi by 2 plus pi by 2 minus alpha. Pi by 2 plus pi by 2 is pi. So pi upon sine alpha into pi minus alpha.